Welcome, everyone. Thanks for joining us, and thanks for being part of our community. My name is Jason Cohen, and I'll be your host for today. A few reminders before we start. If you have issues viewing the stream at any time during the presentation and are using the web browser version of Teams, please refresh your browser. If you're using the desktop app of Teams, please exit and rejoin. Please note that this webinar is being recorded and will be shared publicly. We will post the recordings on our community at aka.ms/securitywebinars. Closed captions in several languages are available during the live broadcast. You can enable them by clicking on the CC button located at the lower right corner of your screen. Feel free to ask questions at any time by typing them in the live event Q&A window by clicking on the Ask a Question button. Be aware that any question you post will be publicly visible. However, if you prefer, you can post your question anonymously by checking the box right below where you enter it. We often get many questions on these webinars, and we will do our best to respond to all of them in real time. In the event if the answer was not provided, or if you may have additional questions post this event, please don't hesitate to raise them on our Azure Sentinel forum at aka.ms/Azure Sentinel community. We love to hear your feedback on how we can improve these webinars. You can do so at aka.ms/securitywebinar-feedback. And by the way, all the links that I'm announcing have been already shared with you on the chat or the live event Q&A window. I would also like to invite you to join our public community by visiting aka.ms/securitycommunity. That's the best way to ensure you don't miss any future webinars or major announcements. On our community, you can speak directly to our engineering teams that create our security products. You'll be able to influence our product designs and get early access to changes by doing things like participating in private previews at aka.ms/prsetcom. Request features, give feedback, review our product roadmaps, register for events, or join webinars like this. We believe that the best way to improve our products is by removing any barriers between you and the people that create them. So we hope you'll join us. In today's session, Ofer Shazaf will take us through a deep dive into Azure Sentinel Normalizing Parsers and Normalized Content. Ofer is a principal product manager with the Azure Sentinel team. And without further ado, I'll turn it over to him. Ofer, the floor is yours.
Thank you, Jason. So today we'll talk about the Azure Sentinel Information Model, as Jason said. We coined it ASIM because abbreviations are always nice. This is a sequel. This is part 2. And some sequels are easy to understand without the first part. I'm not sure this one will be. The links to the first part, which I've done 2 weeks ago, are here in this slide, and Jason will post them in the Q&A window as well. I hope it will be useful for you if you know nothing about ASIM, but it might be hard. If you have questions, the team online will try to help you, but the previous webinar might be a better start. What we will do today? I will do a short recap, not enough. I don't want to repeat everything, but I'll try to onboard those that have missed the previous one. Then we'll deep dive into how to develop for ASIM. Last time we talked about how ASIM is useful to you as a user. Now we'll see how it is, how you can use it as a developer, focusing on parser developers. ASIM is about normalizing data, and we normalize data using parsers. So we'll discuss parser, how to write parsers, how to determine the mapping that parsers would do, and then how to actually, in production environments, deploy parsers and contribute to the GitHub repository or parsers. I love KQL. I'll try to do it a bit interactive and show demonstrations rather than a lot of slides, but there are slides here and deep material. So that's the recap slide. I want to recap fast, so I squeezed a lot into one slide, hopefully not too much. What is ASIM, Azure Sentinel Information Model? ASIM is a layer that enables converting the data that you receive from sources using connectors into a uniform format so that the content, queries, detection rules, workbooks, etc., can all be source agnostic and can be should not be aware of where the data actually comes from. To provide that, the bridge between the content at the bottom of this slide and the connectors on the bottom of this slide and the content on the top of this slide, ASIM, the green part on the slide, provides the following. First of all, there are schemas. We'll discuss them when we talk about mapping. The mapping from the source data has to be to a standard schema that we've defined. So we'll get to that a bit later. But the actual mapping is done using parsers. Those are the core of the discussion today. We create parsers. We already delivered with the schemas a set of parsers mostly for Microsoft sources that enable, and we'll see a bit of examples around that, to unify content across different Microsoft sources. And if you own a device, or if you have a specific device in your organization, you can create a parser that will normalize your own data. And that's the main topic of discussion today. There are two types of parsers. We'll see how they relate to each other in the next few slides. The first one is the source-specific parser, which is specific to your source and translates the input tables into normalized schema. However, when we actually write analytics, we want them to be source agnostic. We want them to not worry about where the source which unify. That's not good. It's really not good.
Sorry, folks, for the disruption here. We're having a little bit of technical difficulties. We're just going to have Ophir leave and rejoin. So we'll be back online in just 1 minute here.
I'm hopefully back.
Yes, we can
Can
hear
you hear
now.
me?
Yep.
Okay. No idea, nothing apart from Teams went wrong, so it wasn't any hardware failure I could identify. Apologies for that, and I'll try to get back to where I was. And hopefully it's the last time. Thank you for your patience. So I'll start again a few sentences back because I don't know where I was cut. The two green bars in this slide represent the parsers. The source agnostic, source specific parser, which translates a specific data source into normalized schema, and the source agnostic or union parser, which combines multiple separate but similar sources into one view for the analytics. Okay, now let's hope that works fine. Now I'm starting to get worried, into how those parsers really look like. So we'll start with what a parser is. A parser is a KQL function, and instead of showing you slides with screenshots, I'll go into, now it's harder to get there, but here, into a log analytics screen, and I'll present to you what a parser is. So I have here, I prepared a few of the queries to save time. This is a regular query that you can do in log analytics. Okay, I'll set the timing to 30 minutes. We don't need more than that to be faster in a webinar. So essentially, it just selects single event ID from security events table, and if I run it, I get results. 4688 is a high volume event. Now, what I can do with this query is I can save it as a function. If I say save it as a function, that's a standard log analytics feature. I can call it the security process event, because 4688 is process event. I need a category name, which is not that important, and then I can save it. It often takes a minute until it kicks in and you can see it. But from now on, security process event is a function that you can use instead of a table name. You can actually have those functions here in this tab. And hopefully already there, but if I'll do security process, yeah. So your process event, you see that it's here. If I go here and I'll do security process event, limit 10. Now, essentially, security process event is an alias. It does exactly security event where event ID equals the number here. So from now on, security process event is for me a table, or for your user a table, and you can do whatever you want with it. Essentially, all we do with Parser in Azure Sentinel is use this concept in order to do parsing and normalization. So the function that we create is more elaborate, it has more in it, and we'll learn about how to do that exactly today. So that slide talks about exactly what I did in a demo. I mentioned two types of parsers. On the right side, you see the source-specific parser. It's essentially a prolonged version of the two-liners I showed you. And we'll spend the time today to discuss exactly how to write this parser. On the left side, we have the source-agnostic or union parser, which is a parser that is very simple. It's just a union between all the source-specific parsers of the same type. You see here that all those are process parsers. One of them, somewhere in the middle, is actually very starts the same way as the example I just brought in. You will need to edit those if you want to add your own custom parsers. You write a new one, as we learned today, on the right side, and then you insert it as another line on the left side in the union parser, which we provide out of the box, and we'll see how that works, or actually we saw last time how to deploy those. So the main discussion today is how to write the source-specific parsers, and how to deploy them, and how to contribute them. That's what we learned today. A source-specific parser is made out of 3 parts. First of all, you'll have to filter, and we'll discuss why filtering is needed. Normalizing sounds like, well, take input, normalize it, and get an output. Why do we need to filter? Get just part of the stream. Then we need to parse. That's a bit more straightforward, as you can expect. You need to parse. That's what a parser is about. And then is a bit breaking the parsing and mapping into 2 parts. Parsing is extracting for longer values specific items, and mapping is field renames. Sometimes just one will be needed, sometimes both. So those are the 3 parts. Let's dive in. Filtering. So why filter, and how do you do that? So there are 2 important reasons to filter. The first one is very, very central to what ASIM parsers are. Your source table, we've seen security event just a minute ago, include a lot of event types. ASIM parsers, each one of them focus on a specific activity or event type. The currently supported ASIM schemas are file activity, registry activity, authentication, DNS network. Each one is just one event type. They do not represent the entire event stream. And therefore, a parser should start by filtering just the relevant events. Another challenge that you may have is that the table that you are parsing includes a lot of sources. Most commonly, syslog and ceph are tables that include a lot of sources, but those are not the only ones. Of course, your custom connectors can share a single table between multiple sources. And the Windows events table, the event table itself has a lot of different sources that are consolidated by the Microsoft Windows event mechanism. So you'll need to filter also to get your specific source. The example below does both, and I'll just go back to Log Analytics. I'll pick, I think it's the second window here. Yes. If we look at the first query here, we'll see there how I expanded to do also parsing. You see that I filter by source because the event table, which represent any event coming from a Windows machine, has a lot of usages. SQL report logs to the same one. And I also filter event ID 1, which is process create. It's the same as the 4688 that we did previously for Windows events. If I run that, and custom here is important because for those that don't know why it failed, is because if you select a part in a query in Log Analytics, only this part is run, and I selected just the part. by playing the mouse. So you get the events, and those are guaranteed to be just the process events that should be normalized into our process activity schema. So that's why you need to filter. We'll get back to this slide a bit later on. Just one thing to remember, do not query a filter by time. The time filter is the job of the query that uses the parser, not of the parser. Now, 2 tips on filtering in general and in parsers in particular. First of all, we are doing parsing, which means that we extract data from current fields, move it into new fields, etc. We need to make sure that we filter the filters we mentioned for source and event type on native fields before parsing. The performance impact is significant if we do otherwise. Sometimes it's not enough because the original field is not parsed, so you don't know. So you do more loose pre-filtering. I'll show you an example in a second, and then you tighten after parsing. Still very important for performance. So this is an example. I did include your time range, which I said just a moment ago never to do because I wanted to measure times. You can see here this is, and we'll see how to do it. This is a syslog parser that actually for Unix that extract an item, the event ID from the syslog stream. Now, if I just want those specific messages, so audit type, it's a specific source from the syslog stream. If I extract first and then try to do a workload, the timing is very, very bad. For example, but if I pre-filter on the native syslog message field, I improve performance very considerably. In this example, not on a lot of data. Actually, it was a lot of data going back. That's why I also do it for 14 days. The line in the middle where syslog message has, and I can probably should move and have a laser pointer. The line in the middle, which does pre-filtering, doesn't change the meaning of the query, but does imply that we have around 4 times faster results, which is very considerable. Another thing to mention, another example, numbers here, I'll show you an example in a second, I don't get this amazing improvement for a good reason. Here, it's a synthetic example where there is a workload that's on a physical field versus a workload which is done on a calculated field. Should be roughly the same. Shazaf doesn't appear anywhere, 0 results. The second one is much, much slower. If I'll go into here, I'll show you an example. Okay, it actually will show you another aspect that we need to consider. So it's a synthetic example. It's not really important for parsers, just to show you the importance of filtering correctly. I take security events and I query the additional info for my last name, which I assume is not there. I'm using the contains operator, which you can see is not recommended. I'll explain in a second why. When I run it, we can expect no results at all, and it's fast. One of the challenges that, let me do that. Maybe that would work better. Better as in slower. Whatever I tell you has the caveat that KQL does have significant optimization. So if I ran something earlier today, I might be in luck. If I ran something twice, it might be very fast. KQL tries to save you from doing those mistakes I'm presenting. So examples not always work as I would expect. They're too fast. Still bear in mind. So this was 6.4 seconds. If I do the same thing with has, still 0 results, it's 4 to 5 times faster. The reason is that has is an index search, contains does not search only for indexed values, it looks for substrings, and it's much, much simpler. Avoid contains when not needed. I see this a lot. And if you really need contains, you may be able to pre-qualify with an has. So search do something with an has, which is faster, and then just the results pre-qualify. Then if I go to the last one, which is a calculated example, same thing roughly. I just added a string to initial info and then search stuff in the resulting string. It wouldn't change because I added something else. This no, of course I should. This will be much slower. I'm not sure I even wait for that. So always search on the built-in physical field in parsers before you do anything else, and then prefer has to contains. And I won't even wait. It's very long. Probably another 10 seconds, and I added a month out there. We'll go back next later. As a reminder, in the slide deck, you'll see a chart of efficient operators, what's more efficient, what's less efficient, so you have it as a reference. I mentioned has and contains, but each one of them would be important. One thing you would want to learn, the has suffix operator is a very efficient one that was added recently. And it's really helpful. For example, if you have a path name and you want to search fast for the file name or extension, has suffix is very useful for that. Now, of course, this was just filtering. I explained why you need to do filtering. Now you need to do parsing. What is parsing? So parsing is taking especially longer fields and breaking them apart into distinct values. Parse is one of the best ways to do it, and the event table that Sysmon is using is a great example because we'll go there in a second and we'll see the result. And yes, it was 84 seconds or a minute and 24 seconds. The example I just showed you, that was 1 second with has. So keep that in mind. It's important. I'll go back to this example. You remember that we ran event where source is sysmon and event ID equals 1. And if you want to, that's getting to the core of normalization. If you look into the results, the event, there's little to do with it. All the data is in the event data field. It's here actually. And that's where parsing normalization really brings a value. And that's something I presented and demonstrated 2 weeks ago, so you may want to refer to that. The question that was left open last time is how is that done? And that's what we're learning today. So in the second example here, I took the same filter and I added a parser. And if I run this one now, you'll see that I have fields such as original file name, okay, broken out here. And you can see that it was done by the parser. It's true for other fields as well, okay? They're just tucked along later on in the so you have the image name and the process ID. All those were hidden in a single textual field and were extracted using the parse keyword. And this parsing is a major element in creating a parser, of course. Now, parse is obviously quite clearly a parse operator. It's not the only one. This is a list of available parsing operators in KQL. They are listed by ranking in terms of performance. What's more performant? Of course, each one does something very different. Split is just split by a delimiter. Parses is just for CSVs. However, parse extractor and extractor are pretty similar. They all take a pattern and parse by it. And you should use parse if you don't need regular expressions. It has a fast mode where it uses a pattern which is not regular expression. If you use regular expression, you can consider all three. Extract is good if you want just 1 or 2 values from the original string. Parse and extract all are good when you want to extract a lot of values from a single source string. A specific challenge to discuss that I want to mention here is if your input value is JSON or XML. It's pretty common these days. There is a parse JSON and parse XML operators. There are those 2 operators. They are relatively heavy and they convert everything to memory. They should be used with care. Specifically, if you just need a value or 2 or even 5 from your XML or JSON, consider using parse or extract to get them out. it'd be much faster. When possible, pre-filter. If you do need parse JSON, make sure that the filtering is done prior to that. I mentioned pre-filtering earlier on, so it's the same advice essentially. Also, we are talking about normalization. We want very specific fields. There's little point in doing pack and bag and pack for those that have been using this method. It's very nice when you don't want to worry about the destination. You just want to get everything from the JSON out or the XML out. It's not very performant, and anyways, we need very specific fields out. And I've also seen the use of the keyword pivot to do parsing for those, and it's probably not what you want. It's probably incorrect. So keep that in mind. One thing that I want to, it's a very advanced topic, but it's important for those that are really into writing parsers. If you have variants, variants is not a good word these days, I'm looking for a replacement. If you have different alternatives to the format, it's very tempting to use separate subqueries and union between them. The challenge is that it's usually very inefficient in terms of KQL and should be avoided. I've done a few where it's the right way to do and where it's efficient, especially if you can filter very well each one to have very different subsets of the data. And in general, that's not the right way to do things, but it is easier. I would consider a few things. First of all, if you do need to do a union, it's something that's very common when you want to do a connector parser, which tries to parse every type of event sent for a connector. That's not what you need for ASIM. In ASIM, we do activity parsers. So they filter just one activity type, which is usually less prone to variations. So you may not need, maybe it's because you're still doing connector parser rather than a activity parser. That said, sometimes there are variations to be considered. You can use case or if to handle those. You can also use extract and all and parse interchangeably to handle variants. For example, in the example we have here, the reason that original file name was handled using extract rather than the original parse, it is just a field in the parse, in the event data field, is because it's not available in each Sysmon version. So we want to make sure that the parser works for each Sysmon version, and we broke out the original file into a separate extend statement. Extract statement. At this point in time, if you are, actually it's a good, we're still in the early days of ASIM. There aren't many experts on writing those. The ASIM team is open to discussion with any parser developer on any challenge you may have. I had my experience of supporting a very, very smart person doing our first vendor ISV contribute parser last week. He did great. He knows his KQL. Still, I could help with his mapping and a few tricks. So now we filtered and parsed. Now we need to do mapping. Sometimes there's no parsing to be done. Sometimes it's just mapping. Sometimes there's not even filtering to be done, just mapping. Let's talk about mapping for a second. So if you didn't know, project rename is the mapping operator in KQL. It renames a field. It has the advantage that it keeps the physical field. It doesn't create a new field. So it's the most optimized way to do mapping. And if all you need to do is field mapping, use project rename, and here you have it. It's the most performant and simplest parser. Sometimes it's not enough. First of all, each parser, when we look at the schemas, each parser have constant fields that you have to add based on the definition of the schema. For example, the event vendor, event product, sometimes device operating system is just a value because your source supports just Windows. So you'll need to use extend when you just assign constant values. You may also want to do extend when you want to do aliases because you want 2 copies of the same field. We'll talk about aliases in mapping later on. And sometimes you actually need to do calculate fields. So that's another reason you'll need to do extend. In general, we do not promote, we don't ask you to remove unneeded fields. It's all query time. The fields are not stored anywhere. And if customers want their original fields, why not? There's nothing, not much to be gained. We did find that sometimes it's a bit confusing because of the new names and the old names, and that's where project away becomes handy by throwing away fields that may have a double meaning if kept from the source alongside the normalized version. In any case, never use project. You don't limit the field just to a set of fields. The original fields are usually important. Now, this was just let me do that. Sorry for that, guys. I do want to make sure that if you want to tell me something. Anyways, there are more advanced mapping capabilities. The most important one I want to discuss is when you need to set up values, normalize values. We'll talk about normalizing values in a second, and those are examples that you need to keep in mind. So, for example, you may have an event ID that signifies failure and an event ID that signifies success. And the schema calls for an event result field which has a success or failure values. So you'll actually have to use an if statement to derive the value of event result, success or failure, based on elements in the original event. Now, value normalization is very important, as we'll see later. Analytics requires normalizing that, checking if an event was successful or failed is important in queries, and if it's different across different sources, it makes writing a source agnostic query very, very hard. Now, sometimes you want to do a lookup. I'll show an example of that in a second, actually this example. For example, our MS-DNS connector returns just numerical codes of the response codes from the DNS server, while most other sources return a name. And we decided that our gold standard is the name, the string value. Lookup is a very efficient way to do that, the way it looks actually in Log Analytics. It was the third or the fourth window. I think it was the fourth window. Yes. So you have a lookup table, which here is embedded in the parser. It can also be a different function. Now, for now, we do it in the parsers. And then this is a partial DNS event parser. I removed all the things. But here you have a lookup. The lookup implies that if we run just that, in addition to the original, where is it? In addition to the original response code, numerical response code, we also have the looked up response code name here. The lookup table looked up each response code and added to each record also the name associated. So those lookups are very important when we have to translate values, because the normalized schema calls for a one consistent value methodology, and different sources may send different codings. Sometimes the lookup is not enough, and the example below is a combined option. It's just that in the same example, the response code can have 4,000 optional values, and we don't want such a large table, but most of them are not really used, reserved for private use. So we've combined here both the lookup, and then we do a case on top of the lookup result, which is just 2 options, and then the default unassigned. So To recap what we discussed so far, we learned that a parser is just a KQL function. The source-specific parser is KQL you need to learn how to write, and then there's the source-agnostic parser. We didn't look at it a lot, that unionized everything else. The source-specific parser has 3 elements: a filter that takes just one activity which you normalize into a activity schema, a parser, for example, using the parse statement that extract values from longer fields, and then mapping. With mapping, I also include value normalization, where you do lookups or if statements in order to not just map the fields, but also map the values to the correct schema values. The next topic we'll discuss, which is a bit of a parallel topic, is how to map. I mean, you write a parser, there is a source schema that's whatever your device sends, and there's the destination schema, which is documented, but how to do the matchmaking is an exercise that we'll discuss a bit now. So first of all, the schemas we have today are network authentication, process, registry, DNS, and files. We plan a few more. One thing to remember is that they are reasonably extensive and they include a lot. They might not be full. For example, the DNS schema is mostly done with thinking about DNS servers, as you can see here on the right. But sometimes you have DNS information sent by a client. When a DNS information is sent by a client, it will have 2 things that a DNS server does not know. It will have a user information, and it will have a process information. So the process and user that initiated the DNS query. The DNS schema itself does not list those fields. However, you can infer them, from the process schema and the authentication schema, which are specialized in process and user information respectively. So the naming should be like that, and maybe we should document better. Maybe we should extend the DNS schema with optional fields to cover also process and user information. For now, that's how we do that. We look into the best available mapping in other schemas. So, as I mentioned, starting point, use the relevant schema. Try to map every available field. Okay, be expansive. A lot of fields are listed as optional. They're optional because you don't need to do them. They're optional for analytics users that can should know that they cannot trust them because some sources will not have them, but you should try to map them as well. As I mentioned, extend using entities such as the process or user information from other schemas. And at this point in time, if you are lost, come and ask us. We have a vested interest in making sure that sources do comply to the schema. And for now, we would really like you to ask if you need. We are here to help you. One of the more complex areas in schemas are entities for multiple reasons, and we defined a very specific way to handle them. The entities are explicitly listed in each schema, so the fields, you don't have to guess them, unless of course it's an extension entity, so like the user entity in the DNS schema. There are 2 things to know about it. First of all, there are multiple entities in each activity. Many times, you have a source device and a destination device. You have an actor, which is the user doing things, and the target, which is the user on which the action is done. Those are the prefixes or descriptors, and they just prefix the names. Pretty straightforward. What are the allowed? What are the specific prefixes, and what's the role is documented with the schema. So I'll take here an example of the. I think the authentication schema has it all. No clicking when I'm in the control click. I wonder. I'll do that. Oh, here you go. So if I open the authentication schema documentation, here's where all the data is, all the list of fields that you need. But somewhere in the middle, we also document what are the different prefixes that you may find and what's the role. And here it's actually not. And here is a sentence that tries to define what those are. An actor, acting application, etc. So it tries to make it more easier to understand what each field based on its prefix implies in the story of the activity. There's a lot of documentation. Documentation is key to normalization and schemas and our whole story here. The other thing about entities are identifiers. And there are many identifiers for each entity. Getting consistency is not easy. We've made a choice here. It's documented. We want an identifier, one that will be the leading one. So for example, the user ID field should be something. You'll find that many events have multiple user IDs. For example, a lot of times you may have the Windows SID and the object ID, which is usually the Azure AD ID, and those are different. We ask you to pick one, which is the leading one. So there is an ID that is the analyst can use as the leading ID, and then also assign a field, a synthetic field with the type. In this example, target user ID type, SID. You can also store other IDs in more specific ID fields, such as AAD ID in this example. Okay. The idea is that there is something called user ID, and it changes between sources, but you don't have to guess which field to use when you write your query. You will have an ID field. And if you want to check what type of ID, you have a type field associated that tells you what it is. Think about an analyst, he's looking for ID, he doesn't want to guess whether it's a Windows ID, AAD ID, Okta ID, he wants an ID field. So that's what we are trying to solve here. It does put a burden on the parser writer to provide this capability to the user. But again, we assume users are less experienced, parser writers are more experienced, so you guys, assuming parser writers, are there to do the heavy lifting. Two additional concepts around schemas. First, field classes. In the schema documentation I just showed you here, there are three classes: optional. It's all optional here. Oh, optional, mandatory, and recommended. Mandatory implies that we expect every parser to include that. And it also means that analytics, any query, it can assume that the value is there. It's not a large number of fields. They many times do require also value normalization. So looking up not just the right field name, but also the right values in it. Those are documented in the table. So for example, for event result, which we discussed, there are 4 valid values, which we'll have to map into. And those are very important. Analytics works on that. And our choice of what to do there is based on our understanding of what analytics requires. For example, event result is very common. We found that in the networking table, the device action, what the firewall actually decided to do, is also very important for analytics. So it's a mandatory field. Recommended fields are fields that, if available, should be mapped. That said, on the other side, if you write queries, you cannot blindly assume they're there because some sources do not have them. And optional fields is the larger field. We try to make sure that if fields are available, they have a consistent naming. So those are the optional fields. There are many of those. If you map them, map to the right name. If you don't, that's important. I did discuss in length value normalization. I brought an example of event result. This is really important because without value normalization, source agnostic content is close to impossible. So when we ask that the parser gets you just specific event types for event values for event result, it is really important. And when you contribute, when you do things at your organization, it's your choice. When you contribute, we will verify those when we approve and include parsers. We discussed value normalization in terms of list of values, so enumerated types. It also applies to formats. We have specific assumptions around what is the username, how it's formatted. I'll give you a simple example. A domain name, fully qualified domain name, with the dots in the middle. You think it's easy. It's very consistent. That said, most DNS servers actually report a domain with a final dot at the end, which kills detections. So when you do a parser, we actually ask and document that to remove the dot from the end. That's another value normalization example for you. The last thing to note here, you'll see it when you go through the schemas, is aliases. We sometimes want to have two names for the same field. With QueryTime, it's pretty easy. It's using extend. Why? Because users are accustomed for two names. We have users, our analysts, and we decided we can't anticipate what they actually want. And sometimes it's because we want an easier name. So instead of target process name, just process. So there's, if the analyst write where process equals, you get something. It makes, in general, ASIM makes life much easier for an interactive analyst. So that's why we have aliases. So we discussed mapping. Mapping, unlike KQL, which I hoped I was pretty extensive in, mapping is a large topic. Each one of you will encounter a specific source to map. I showed you one schema document. There are 6 of those, and we are expanding. So it wasn't comprehensive. Any questions? We'd love answering. And sometimes it's not just questions. Sometimes it's actually comments. It's feedback to us. ASIM is new. The last topic we will spend a few minutes on is deploying parsers. I presented one option for deploying parsers, which was just saving them in the workspace. Of course, this is not very scalable. If you want 10s or 15 or dozens of parsers, the way that you deploy parsers in real life is using ARM templates. There is an example ARM template on the GitHub. This is actually useful. You can actually run this template. I'll show you what the link to it should be. Do I have it here? Yeah. Yeah, you can use deploy to Azure. I'll show you how this URL to that is built. And when you do deploy to Azure, you'll get a screen that asks you for the target workspace and the query that you want to deploy. Obviously, in production environments, and we'll wait a second for that. So, the workspace name, location, and then the alias, the name of the function, and the parser code. That's an example. In real life, what you want to do is you want to embed the function alias and the JSON in the template itself, so they are constant, and the only question is what workspace to deploy to. So if we go to use this example, the link here to, yeah. So if we go here and we deploy this one, it's info blocks where we need a parameter actually. You'll see a similar screen. It doesn't ask for the query or the alias, they are embedded in the template. But it does ask for another parameter, okay? What are the info blocks computers? Because it's important for filtering. That's the way that we know from the syslog stream how to pick the info blocks computers. So modify the example as you need. Embed the query and alias in the template itself. Remember that it has to be JSON escaped. So your query will probably look something like security event where event ID equal 4688, but this is not the way it should be in the template. In the template, it should be like that. Okay, a single line, \n for new lines, escaping, etc. So don't forget that. I'll show you in a second a simpler way to do it. Lastly, I used a few times a link to run those deployments easily. This is the way the links look like. Sorry. Very easily, just a way to deploy a template in the portal, and then you have the URL to the template, which can be a GitHub raw URL. Again, remember that the URL here has to be URL encoded. So if you have you develop your parser, you want to distribute it, translate it into a template, and then it's clickable. One thing to also consider is you can combine multiple parsers into a single deployment. There's an example here in the link. That's the way we do with our Microsoft built ASIM parsers. Now, the last element here, which is important, is that we don't actually write using ARM templates. It's cumbersome. We use YAML. We use this YAML format. You'll see it in the ASIM folders in the parser directory on the GitHub. And they include, you see, the query in readable format, not after JSON encoding. And that's the way we expect contribution to be made. Write such a YAML and upload it to your to the parser. So do a pull request somewhere in your product in the parser folder in Sentinel GitHub. And we'll verify and we'll approve the pull request. We'll take behind the scenes the job of translating it into a template and also including your parser in the union parser. Okay, so that's our job. That said, we also provide you, Yaron was here on the call, did a fast job to help me show you today, a script that you can download that translates this YAML to a template so that you can test. Again, when you contribute in YAML in the parser folders on the Sentinel GitHub, and we'll take it from there. But you may want to write YAML and still check and deploy. You can use this script, which is in the tools folder in the GitHub, in the Sentinel GitHub, to generate a ARM template and deploy easily yourself. So I hope that all I said today will help you contribute parsers, create for yourself internally at the organization or contribute parsers, and get the full value of ASIM, not just but what we provide today, but also by what you can add. And that's it. Team online, any interesting questions from the chat that's worth raising?
Yeah, we got a few. So first one is, how well can the product handle fields being parsed in logstream processor products before reaching it, i.e. Cribble or Elastic? So long as I map to the standard field names, does it matter if I parse them before the cloud, or does that simply offload that function from how you're doing it currently?
Okay, so today, this will change over time. Today, if you do parsing prior to the workspace, it implies that you are writing a custom table in log analytics. When you write a custom table, you can get the right columns, but the column name would be a bit different because there's a suffix with the type. So you will still need a very simple parser that just do essentially project renames. The advantage is, of course, performance and also a much less KQL knowledge writing the parser. We do plan in the future to enable source parsers to write directly to normalized tables. That requires an update to the log analytics API, which is in the works. So I hope that was helpful.
Great, thank you. The next question is, suppose a scenario where someone has disabled endpoint and got the logs from Windows operational events via the agent. In case I want to push automated scan on the same endpoint using Defender for Endpoint from Sentinel Playbook, I need machine ID in entity fields, which is not available. How do I get the machine ID?
So the machine ID is available. That's why I mentioned upfront somewhere that we don't do a project away or a project. So when we do, I don't have enough time. Sorry, I wanted to demonstrate. I can only demonstrable. If you use a normalized parser that combines Defender for Endpoint, you will get a machine ID field that will be populated just for events received from Defender for Endpoint, which is, as you can expect, for other systems, it's not available. I want to have with a footnote at the end. So you can do a playbook that will check if the value exists and then do whatever is planned. So we don't throw away the value in our built-in parsers, and we did a lot of Defender for Endpoint and essentially EDR things. And as I mentioned in the webinar earlier, we don't recommend you, when you build parsers, to throw away fields. They will not be normalized, but they will be available for the relevant sources. There's a second aspect to that, which is enrichment, which is an interesting topic, less the topic of this webinar today, but really interesting to think about a process, say a playbook for that matter, that actually maps host names and IP addresses to device IDs from Defender for Endpoint information and enables to apply those to other sources as well. So it's a great idea. I didn't think about it. Maybe it is part of normalization. Sort of. I heard that actually Jason here online mentioned to me once that normalization and enrichment are tightly coupled, and people see them as related.
Great. Oh shoot. So is there some query to see if global admin access to OneDrive of any employee?
I don't know. I'm not sure it's normalization relevant. I mean, as doing normalization, we do drill into a lot of data, but we're a bit single-minded about making sure that it's uniform rather than what it is. We do learn what it is. And I think that we need to funnel this question to Mystic team, our research team, to see if it's possible given any specific event stream.
Great. We got two quick ones here. Is there any limit on the number of parser operations to run on a single type?
No. So I can take this question to many directions. You said it's fast mode, I'm not sure. Essentially, because it's query time, you can use the same information in many different parsers. You can present it to different analysts in different manner. So generally speaking, the answer is as many as you want. The question is how many do you want? But yes, there's no limit.
All right, and the last one is, are there any more normalized parsers for other log sources being worked on that will be released soon?
So we are building a plan. My team with Yaron and Yuval are here in charge of the concepts, the schemas, and we are doing proof of value, which focuses on most on first-party sources. We are now extending and starting to work with a team that will do the more as part of building connectors. We'll make sure that they have normalizing parsers, but I don't have a timeline yet for that. It's not a heavy lifting. It's just a lot of work because there are so many sources. And then I'm doing that so that you will contribute, and certainly if you are a vendor, to make sure that when you build a connector, you work with us to make it normalized.
Okay, and real quick, we just got this one. How to bulk close incidents in Sentinel?
Oh, I'll defer. It's important, but it's not the topic of this.
Okay. Cool. Well, thank you, Ofer, for being our guest today and for an excellent presentation. And thank you to the rest of the team who helped answer questions. At the same time, I would like to remind the listeners that the best way to ensure you don't miss any future webinars or major announcements is to visit our landing page at aka.ms/security-community. And while there, you'll find easy ways to navigate and find the resources and learning content relevant to our security products and their communities. A good start would be browsing our bite-sized product videos, ninja trainings, recordings of past webinars, GitHub communities, and more. We'd love to hear your feedback on how we can improve these webinars. Please take a minute submitting your webinar feedback at aka.ms/security-webinar feedback. Thank you and see you next time. Goodbye.